So I'm Joe Smith, and I'm a technical evangelist for Vista, and we're over here in Building 10's 27th security guys, and they're developing some new cryptography technology for Windows Vista.
Yeah, and so we're in your office. Yeah, actually, you share an office, right?
Yeah, we share an office.
Yeah, yeah. So, and who are you guys?
I'm Tomas, Senior Crypto PM.
Okay.
And this is?
And I'm Tolga Acar. I'm a program manager in cryptography.
Great. And so,
So
what should we start out? Or
well,
I have no clue. I'll tell you. I'll be honest. I have no clue what crypto is.
That's what I'm going to say. So what is it at a really high level that you guys are doing? What's cryptography? Why do people use it? I mean, some people are going to know what crypto is. I mean, I get the idea it's encrypting, a stream or a file, but how do people really use it, like in their applications and in Vista? What kind of scenarios are you guys targeting?
Before going into scenarios, crypto actually has been used for a number of years now, and now we're at a point that whenever you want to use cryptography, you turn to and say, okay, what's the protocol I want to use? So some of the ones that you're familiar with, probably like SSL, it uses cryptography all over the place.
Yep.
Like IPsec, likewise. Yep. Or like encrypted email, S-MIME for short, secure MIME. And it's all about cryptography underneath. And we provide the guts under all of those protocols. There are other protocols, but I'm kind of not mentioning those now.
So do you guys actually do the protocol itself, or you really do the cryptographic mechanism that makes the protocol secure?
We provide the mechanisms.
Yeah, actually we're doing both in a way. We do the core cryptographic feature that everything else is built on, and then both Tolga and I have been targeted to take it up the stack, up to Office, up to other components that have been less cryptographically agile in the past. And we're pushing that initiative across Microsoft and out to all the governments and also the financial verticals and things like this, so that way Microsoft and our customers can respond in a much more agile fashion to cryptographic changes.
When you say not cryptographically agile, what's an example of something that's not cryptographically agile?
Hashing functions for one. Yeah, hashing functions for one. MD5 hash, which a number of clients have always used in their software, it's been broken. SHA-1 has gotten weakened cryptographically. And because of this means that the people who are depending on hashing functions will need to be able to swap them out just to SHA-2 or another hashing function in the future as they become weaker. Cryptographic algorithms are getting weaker faster than originally projected.
And that's it. I mean, from my understanding, which isn't huge, but that's the big thing about cryptography. It's almost like a race, right? It's a race to see how long will it take an attacker to break the cryptography versus how strong the cryptography is over a period of time. So you guys are anticipating the fact that something's not going to work out. SHA eventually isn't going to be what people really want, so SHA-1 isn't. So they're going to want to swap in SHA-2 without rewriting their entire application or changing the way they...
Exactly.
That's the idea.
Yeah, so that way we're moving up the stack, so that way Word doesn't have to change, email, as Tolga referred to, won't have to change in order to handle plugging in of a new signing algorithm or a new hashing algorithm. It'll just work, and that's our mantra. It will just work.
So I've heard that the acronym CNG, and that stands for Cryptography Next Generation. That is the framework that allows you to plug in the new algorithms.
Yes.
So you guys are shipping that with Vista.
Yes.
Yes.
Are you also shipping standard plugins? I mean, when I first write my app, do I have to go invent discover, read the RFC on an algorithm and implement it myself, or do you ship some standard ones?
Let me mention it, I'll pass it on to Tomas. It comes at different levels, and those are levels we have essentially in CNG. In the bare crypto, raw crypto, algorithm level, there are all sorts of interfaces in CNG, so if you know what algorithm you want to use, if you have your own protocol, you could talk to CNG and get it done. But if we're talking about protocols, one layer up,
okay.
You can also plug in, for instance, at the TLS level, SSL level, we have a plugin architecture that if you have your own, you can plug it in, or use the one that will be shipping in Vista. So we're doing both.
So it's the best of both. You give me a standard set of ones, and then...
Yes, everything that CAPI-1 and the traditional legacy cryptographic algorithms that were supported with CAPI-1 are in, plus ECC, AES, and all the heavy-duty SHAs, and the ability to plug in your own stuff down the line, Whirlpool or whatever makes it through validation in the future.
Sure.
That's the whole goal behind this. But you're not losing anything. You're actually gaining a bunch of things, and you're gaining performance. That's the other thing that CNG does. Some cases we're 3 or 4 times faster than CAPI-1.
I mean, to me, I would think that's huge because, I mean, HTTPS is one of the most typical ways that, we see cryptography. It's probably like an everyday user experiences cryptography, but that they realize not with HTTPS. So when I send my credit card over to server XYZ, it's going over an encrypted channel. And that's a lot of transactions frequently. And what really slows that down is a lot of times the cryptography of the stream, right? So you're saying people are going to see like a tangible performance.
Oh, they will see
Yes.
a tangible performance. In addition, CNG allows hardware support, right down to the primitive cryptographic.
And that wasn't available before.
It was, but the problem with CAPI-1 was that everyone who's worked in crypto before is that if you wanted to implement one thing, you had to implement everything. And so the granularity here is at the protocol individual algorithm layer. So you can do a hash, asymmetric, symmetric, right there.
Or even at the protocol level. If
And
you
even at the
choose
protocol.
less flexible that we're introducing before, it was either you had to do everything or you couldn't do anything. So much more flexibility now.
Let's hold on just a second. We're back. We had a little interruption there. Who uses crypto and why do they care about? Who cares about it? Is it a developer? Is it a mom and dad?
Just about anyone who wants to protect the information that they work with. This goes all the way from all the secret agencies around the world, the governments, the financial verticals, the banks, anyone moving money around, let's see, who else do you think of? I'm missing someone. Oh, healthcare.
Healthcare,
Yeah.
Financial, fiduciary, definitely military, and pretty much any government I can think of.
Well, even then, I mean, from my experience, when I used to be working in MS Messenger, even simple apps like that, it's simple, but even a normal end user application cares about it if you have that privacy information, right? I mean, you're just legally obligated to protect it.
Yeah.
Yes, exactly.
For instance, if you really want to generalize, if you have data on a network in a cryptography,
I mean, there's a lot to say for that.
And it doesn't stop there. For instance, there are some regulations like Sarbanes-Oxley (SOX) that it doesn't stop at network. It also has requirements that what you store on your hard drive. In some cases, in order to comply, you have to encrypt your data on the hard drive.
So that brings up another person that would be highly interested would be, I guess, people that are writing software for certain government agencies or defense contracts or homeland security might. I mean, from what I understand, you guys have you're meeting new government standards that Windows hadn't been able to meet before, and you guys are kind of.
That's correct.
Solving some new problems for our government.
That's correct. We're giving them two things, and not just the United States government, the governments around the world. One thing is that we're meeting what's called Suite B, cryptography standard for the United States, and the equivalent in countries around the world. The other thing that we're doing is we're allowing security agencies and those who really don't want to share the cryptographic algorithm with anybody to be able to plug in their own. So you'll have the NSA or the Chinese government or any of those people plug in their own stuff, and Windows will continue to work and use their encryption techniques for signing, encrypting, hashing,
I
whatever.
mean, does that mean, from a practical perspective, like, let's say the NSA wants to use, Vista within, Office 12 and all this stuff, but for whatever reason, when they save certain types of documents, they have to be saved under a certain level of encryption or what have you, that isn't generally available in Vista. Could they have a custom provider written in so that when they wanted to use, Office 12 and Vista pretty normally, with this extra cryptography thing, how would that work?
If they're super secret NSA
Yeah.
spies. Yes, exactly. And as a matter of fact, this is what's giving CNG traction around the world, is because with the governments, it's like, my gosh, we can actually plug in our own stuff and continue to use Word and use SSL, but with our own stuff. That is a very powerful story for Windows. There isn't another OS out there. They have little bits and pieces, but not in a way that they can just be plugged in.
How does crypto work at its basic level?
It's mathematics.
Okay.
prime numbers, randomness.
And so if you showed me one of the files, I would just see random strings of stuff.
Hopefully you wouldn't see a pattern.
Yeah.
I mean, so the goal, I mean, so cryptography is, I mean, I'm simplifying, I mean, so what you guys do, it's at a basic level, you're given a data stream that might be extremely legible at first, even if it's XML or if it's credit card numbers or Word document or whatever.
That's called plain text.
Plain text, right? And it's a cipher, right? It takes it and, you know, in layman's terms, jumbles it all up, right?
Mm-hmm.
So it would look like gibberish. But for to understand that, you know, the algorithms are actually pretty complex that actually make this function so that there isn't a resultant pattern and you can't work backwards.
A lot of mathematicians work on both the creation of crypto and the breaking of crypto. So, and Tolga knows about that.
And how, I mean, have you guys taken any measures to make, like, what kind of measure, I'm sure you have, what kind of measures do you take to make sure that, you know, reverse engineering is less probable?
Actually, reverse engineering is not really a problem for cryptography.
What about cryptanalysis?
Cryptanalysis is definitely a problem for cryptography, which is totally separate from reverse engineering, though. Nonetheless, we rely on, when we, for instance, add a new cryptographic algorithm, we rely on public cryptanalysis and scrutiny. And that
Can
we
you
also
explain
rely
what
on
cryptanalysis
yeah.
is and reverse?
Let's say you come up with an algorithm. Let's say you're going to encrypt something, so you have an encryption algorithm. So how do you know if that it actually is secure and actually gives you the security that you're after? And then we start talking about like number of bits in your key, secret key, or whatever key you have. And so how do you prove that? We rely on all the cryptographers or the cryptanalysts out there across the globe, and they do their own analysis, and there are certain attacks, and some of them are, yeah, okay, some of them you say, why would I care, things like that. And we rely on our MSR, Microsoft Research. We get constant feedback from Microsoft Research on most of the cryptanalysis results.
So cryptanalysis is, you know, kind of like hacking for cryptography. It's kind of trying to take the output of the crypto function and find a way that only taking the output, I can match it back to plain text, or I can match it along with plain text to understand what your algorithm actually is.
That's the way, definitely.
And
Yeah, I think less nefarious than hacking, no. I mean, this is truly a discipline in its own right, because the whole goal is to provide security through encryption of your data. And so, like the people who create these things, they're people who honestly, legitimately, legally want to find weaknesses in there to ensure your data's secure.
like penetration testing for secure systems. Is it similar to, I mean, analogous to that?
It's slightly different. I think one thing is very well worth mentioning. There aren't anything secret in cryptography other than keys.
Oh, really?
Algorithms are not secret.
Yeah, that's what a lot of people
Implementations are
know.
not secret.
Well, that's
Mathematics are
interesting.
not secret.
So when you actually put out the algorithm you use, if it's, you know,
It's public. Anybody can go in and implement it if they choose to do so.
Yes, and that's the power behind cryptography. Security through obfuscation is not security at all. If you can say, this is how I'm securing it, you're telling them how. And they can't do it.
So what keeps it secret is, given a particular key entered into the algorithm, it's the key that actually keeps things secret.
Exactly.
But the algorithm, you can just go out and say, given a particular key, this is what it'll all do. You just don't know what the actual key is. So that's one of the ways you guys are keeping it safe and making sure that it works the way it should, is because you can actually put the specs of this algorithm out there, and lots of people that are, you know, brilliant in this field can actually analyze it.
Exactly. From a cryptographic point of view, if you haven't published what you're doing in an algorithm form like Tolga said, people are just going to go, psh.
Now, when I hear about crypto or breaking it, they talk about having supercomputers and how long it would take. So, like, SQL Server team has a 64-way, 64-bit, you know, HP Superdome computer. So, how long would that thing have to run to break a modern, you know, algorithm?
Well, that's a good question.
Depends on the algorithm,
Yeah.
but typically years, if not decades.
Wow.
Depends.
And
Depends on the algorithm we're talking
And
about.
practically speaking, if you were to switch your key every month, or switch your password every couple months,
Yeah, it's really not right to make such a blanket statement because it really depends on what you're doing. If you're talking about authentication, sure, who cares? Because you're authenticating right there on the fly, and tomorrow it's irrelevant. But if you're encrypting data, like if you're encrypting your email, yeah, maybe what you put actually in your email is still relevant like 10 years from now. So that's why there are some categories, like our government has categorized inside Suite B for what kind of data classification, what kind of minimum key lengths that you're supposed to use.
Yep.
Right.
And is there any unbreakable cryptography then?
Breakable?
Unbreakable.
I would.
The only thing known is the
Absolute.
one-time pad, which is not practical and it's not used. So you need to define what unbreakable means. And nothing in crypto is absolute.
Interesting.
Given enough time, given enough resources, you can break anything.
Okay.
And you still need that shared secret anyway, the one-time pad. It's like you're both using the same Encyclopedia Britannica once,
Yeah.
and you have this way to map the characters to each other. Okay, that's secure. Use it once.
And then you have
Because
to
that's-
start all from scratch
Yeah,
again,
right.
share the secret again. So for a second to get away from the particular cryptography stuff, in Vista, what are the APIs people are going to use to kind of take advantage of this? Even at just a basic level, I want to write my, I'm writing a P2P thing, or I'm using, PeerNet to talk to you in Vista, and I want to encrypt that channel.
I'll let Tolga talk to the provider side, the protocol provider. But from the C&G point of view, there are going to be three classifications. One is bcrypt, which allows you to do the primitive encryption from both the user space and the kernel space. So that's new for Vista. There is encrypt, which allows you to do the key storage providers, which is sort of like the CSP, and there's cryptoconfig, which allows you to build up the association and relationship of the default cryptographic algorithms that are going to be used for your particular context. You can say, these are bundled together. I only want Suite B algorithms here to be used on this machine, and so only Suite B algorithms will be loaded. And then Tolga can speak to the protocol.
Yeah. If you're developing your own application, I'd highly recommend that rather than coming up with your own decisions, use an existing protocol like TLS, as we provide as a protocol provider, or IPsec or S-MIME, or something similar to that. Unless those protocols don't give you what you really need, then yeah, you probably need to go down to primitive levels, as Tomas mentioned.
How do you judge the protocols? I mean, when I'm a new developer, how do I pick from the menu of protocols?
First, if you're doing any kind of network communication, there probably is something already out there that you shouldn't invent something new.
Okay.
Probably what you need to do is, if you want to know about the details, IETF is a great site in an engineering task force. Go check out there, see if there's something already available. I bet there is. If there's something local, we have like our key containers or DP API or something similar. You can use them directly.
So you've been talking about the provider end of things and using the typical providers and all of this, but what's kind of like the highest level interface in the entire cryptography library? Where is the place, where's the function call where I say, here's my stream, encrypt it with this particular algorithm? Does that exist? Am I thinking about this?
Yeah, those are the primitives that I had mentioned earlier, those other APIs. As we start growing and start abstracting away some of the more difficult aspects of dealing with the primitives, it's significantly easier than Cat V1, but for our standard developer, we're going to depend on managed code for the .NET people, and we're going to depend on the creation, excuse me, of a abstraction layer to say, here, go encrypt this, go hash this, and whatever. And I'm sure that there are going to be lots of people writing their own and having fun like I do, and Tolga does, writing their own. But eventually, we're going to be adding that into the Vista.
And so have you guys been talking to some of the CLRI guys and .NET guys to say, I have my I know in .NET there's the CryptoStream provider. There's a CryptoStream, something like that, and
There's security cryptography.
that'll be so your guys' work will end up we'll end up seeing it in CLR at some point.
Yes, yes. The whole goal is the whole cryptographic story for Microsoft and our partners is going to be rules and controls, so that it's consistent across the whole product line, and that will include CLR, of course.
Cool. So people were. What was the name? I mean, I know that so this exactly as Viz, or with a lot of the cool stuff, didn't exist before. But what was the thing that was this in XP? What was it called?
Cappy 1, and then there was Cappy 2 that sits on top of it. Cappy 2 is mostly certificates, but it did an abstraction on top of it. And then, of course, there was the original .NET crypto API stuff. But Cappy is very monolithic, was slow. A lot of people went around it.
And it wasn't available in kernel. One thing we're also adding with CNG, we have pretty much the same APIs making them available in the kernel land too. So if you have a kernel application, you can use the NG kernel.
So there's going to be some really hardcore dev out there that's going to get really excited when he finds this out. Like he can use the kernel level.
Oh yeah, I mean that was one of the things people said. You can use the same APIs from the kernel. Yes, all the primitives are available.
That's interesting.
Yeah. So and same signature, everything. So it's going to make it much easier. And our plugin model is so much easier now.
Mm-hmm.
Because of CryptoConfig, you basically take your provider, you plug it in, you register it, you say, can you run in kernel? Do you need to run isolated? Isolation is another important part.
What's isolation?
This is part of what's called common criteria, and that means that one of the requirements is that we cannot bring private key material into the user space like it was done with Cappy. We have to keep it isolated. And so now it's over here, and your application's over here, and you're getting all the keying support, but you don't have to deal and have to worry about the keying material showing up.
Why do you have to keep it isolated? Is that because I could have some user space application that could kind of like look through your memory and happen upon the key? Is that what it's basically protecting?
Yes, it's like it's a red key leakage issue. You lost control of your key, and this is why it's part of the common criteria. The cryptographic algorithms are expected to support this particular mode. It's like the FIPS mode originally, where they say you have to have a certain level of support, and common criteria is the newer one that we're supporting.
Cool.
Oh yeah, it's very cool.
Some of this stuff is just, I mean, some of the stuff is a little, pretty niche, but I can see if you're trying to do, the government, I could see where some of that's broad applications, some of the kernel level stuff, I mean, you're going to really meet some needs of some people that were probably felt a little neglected before, like, the Windows story, Windows API weren't really, were in meeting their needs, and some of these people are big government agencies, which is
I've been told that they've been asking for some of the things that we're providing with CNG, and they've been asking for them for 10 years. And, everyone is pretty comfortable with staying back in the old model because the cryptographic algorithms were fine. They were holding up. And then they started falling off one by one. And so now it's become very important to everybody to be able to protect their secrets. And CNG enables that. And continue protecting them. And besides that, how many devs want to keep writing the same thing over and over again for crypto when they can just say, use this? Yeah, right. But see, we have a new hash algorithm, we have a new sign algorithm.
Absolutely.
You configure to use that, and you don't have to worry about it.
Awesome. So?
I'm way over my head.
Oh, I think we're good.
Is that okay? My mouth was getting dry.
Oh, no, this is cool stuff. So,
And we also have blogs on MSDN and
Yeah, we have blogs out there. They're welcome to go to the blogs. Tolga and I are very responsive to the outside. We both are ex-devs.
Yeah.
So in fact, we're still devs at home.
Yeah.
So we're willing to dig in and answer the questions, and that's part of one of our goals is for.
So these guys will, is there any forum where, like, if I'm interested in this stuff or I'm using it, I run into a block, where do I go for support?
You can go to our blog, which is available now on the outside, and there's one for original Cappy and there's one for CNG.
Both on MSDN and TechNet.
Yeah, and actually at the PDC, they the presentation that's being given will have the links there for both and our email aliases. They can send mail directly to us if they want. Yeah, we're living on the edge.
Are you really? You're
Yeah.
publishing your email license?
Yeah,
Yeah, we are.
You are brave.
yeah, we're brave, but
Hey, my cell phone's on my blog.
we're not putting our home addresses on there.
What are you guys doing at the PDC?
Actually, neither Tolga and I are going because we're getting Longhorn out, but my dev lead and the and Ari, who is the PM for our protocols, and Avi is going down.
Avi is going, yeah.
Yeah, and Avi's going down.
They'll be presenting the details and all this stuff.
They'll be presenting some decks that we presented, built for them, and going from like the 30,000 feet, because there's a lot more to Vista than CNG. I mean, we don't like to say that, but
Yep.
Sure.
But thanks for showing us, and thanks for improving a little piece of Windows Vista for us.
oh, quite welcome. I appreciate it.
And I know we'll all appreciate it when our banks don't get ripped off and
Yes.
stuff like that. Thank you very much.
Thank you.
You bet.